a different way. So we're going to start and look at domain. So domain is the set of all of our inputs, which means it is all of our what values? X values. Okay, and then range is the set of all outputs, which is our values. Now, the next thing we're going to talk about is maxima and minima. That's just the same thing as maximum and minimum, okay? So when we have a maxima, when we have a maxima, it is the greatest outputs, so the greatest y values of the function, yes? Yes. Okay, if we have a minima, we're talking about the least outputs or the least y values of the function. If we have an axis of symmetry, it's an imaginary line that divides the graph into what? Two equal parts. Okay, but we're going to say identical. We're going to go a step further than equal. We want to make sure that both sides look the exact same. They should be mirror images of one another. Okay? But one more thing about maxima and minima that I forgot to do real quick was if we have a max, we are looking for a high point. If we have a min, we are looking for a low point. Okay? And we're going to use just the y coordinates for that. Now, the next thing is x-intercepts. X-intercept is where the graph crosses the... And then the y-intercept is where it crosses the... Yes, Priam, what you need?
Could I use the restroom after?
When she gets back, yeah. All right, now, all of that we have talked about in some context before, okay? The next thing, though, is something that's a little bit different than anything we've talked about. I think we might have mentioned it, but never really spent time on it. So we're going to look at intervals of increasing, decreasing, and constants. So in this section right here, we're going to look at moving from left to right across our graph. Just like we read a book, that's how you read a graph, from left to right, okay? So if we're going from left to right, am I looking at my x values or my y values? X values, okay? So when we look at our x values, okay, we're going to look and see how the function may increase, decrease, or remain constant on certain intervals. So this is where the 3 different colors highlighters comes in, okay? I want you to grab a highlighter, it doesn't matter the color, and I want you to highlight the word increasing. What does the word increasing mean?
Rising.
Rising, going up. So if I look at this graph, I am not going to pay attention to the arrows. Those arrows just tell me the graph continues forever, okay? We are looking at it from left to right. So as we go from the left, and I draw this line, am I drawing up or down?
You're going up.
So that means we are
Increasing.
Okay? Now, the next section, we're going to switch colors, and we are going to highlight constant. What does the word constant mean? Stays the same. So whenever we look at this flat section right here, that is considered constant. It's not going up or down, it's remaining the same. And then we're going to switch, and we're going to highlight decreasing. What does decreasing mean? And as we draw this line, what are we doing? Going down. Okay, so that is the differences between increasing, constant, and decreasing. Okay, so we're going to actually write out the intervals now. So when we are looking at the intervals, we are going to list the x values. Okay, so from the left, where does that purple section start? It's going way, 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 way out there. Negative infinity. So it's going to go from negative infinity to what?
To positive.
No. We're just looking at the pop. What's the x value right there? It's not 0.
Oh, we're going to the x.
Oh, I meant -1.
-1. Okay. So we're going from negative infinity to -1. That is the section that is increasing. We are just putting the x values where it's increasing. Okay. Now, for constant, where does the constant section start? What x value does the constant section start?
It starts at -1.
-1. And then where does that constant section go to?
Like
I think it's 4. Okay? So negative 1 to 4. Okay? Now, decreasing. At what x value does it start decreasing? 4. And that's going to continue on. It's on the right side, so it's going to continue to infinity.
Negative.
No, it's on the right side. So we are looking at x values.
Oh.
So it's positive infinity. Okay? Now, when you're doing intervals of increasing and decreasing, you are going to use parentheses. Okay, the reason for that is actually because what we're going to do, okay, we're watching Fast and Furious, right?
Oh, yeah.
We are watching it. They are getting ready to speed down the road. They're already going 100 miles per hour, and they're going to be going like 120 by the end of this. Okay? But it's watching. We're watching it, you know. And they're driving. They're speeding up. You know, speed up. Yep. And we pause the screen. And as we pause the screen on the speedometer, it says 110 miles per hour. So when we pause it, what speed are they going?
110 miles an hour.
Okay, so at that exact moment, are they increasing anymore?
No.
No, they're just going 110, right? And so that's the same reason we use a parentheses with increasing and decreasing intervals. Because at a moment, you can't increase or decrease. To be able to increase, you have to have a whole interval. And so remember how brackets meant you can equal it? Well, if we're increasing and we put a bracket, it means at 4, it's increasing. Or at 110, it's increasing. Is it increasing at 110?
No.
No, you can't be increasing until it goes from 110 to 111. Does that make sense, kind of? That's where that comes from. And it's just because at a singular point, you can't increase. You have to have a big, huge interval, and it will never equal. Y'all stop. So now, we are going to go ahead, and we are going to do an example down here. But before we get started on the full example, what we're going to do is we're going to lay out by each thing what we use for that. Because different things we use either the X or the Y. And it can get confusing trying to remember all of those. So we're going to write them all out. So when we are doing our domain, we are going to use X values. Not just are we going to use X values, but we're going to go from left to right. And for our range, we are going to use our Y values. And we're going to go from bottom to top. Okay? And if you want to include here at the top, if you have an open circle, remember, if you have an open circle or infinity, you use parentheses. But if you have a closed dot, you use a bracket. Now, for minimum and maximum, it's just the Y value that is the greatest or the least. For axis of symmetry, we're simply going to do X equals whatever that axis is. Okay, then for our intercepts, we are going to put the actual point of the intercepts. So we're going to have to look at both the X coordinate and the Y coordinate. Then when we look at increasing, decreasing, and constant intervals, okay, we are going to use our X values. And we're going to go from left to right. And again, for these, you will always use parentheses, okay? So if we can remember this information, we'll be able to do any of these type of problems, okay? So we're going to go ahead and look at this example. So we're going to focus on this graph here to the right. When we look, what is the domain of this? What is the leftmost point of that graph? -2. And it's going to go to where? Infinity. -2 has a closed dot, so that means we need a bracket. Infinity needs a parentheses. Infinity will always get a parentheses. Jairi, wake up. Now, range. What is the smallest Y value? 0. And the biggest is going to go to?
Positive.
Yep, and so we'll do 0 get a bracket and infinity gets a parentheses. Now, our min, what's the smallest y value on that graph?
0.
Now, max, where is this one, what's the biggest y value it goes to?
3. Infinity.
Infinity, right? It goes on forever. Okay? We're not looking at like the act. When I say the graph, I'm not talking about the grid. I'm talking about what is graphed on the graph. Okay? So, if it goes to infinity, is there a true max there? Is there really a highest place it gets?
No.
No, because it goes on forever, right? So that means for our max, it is simply none.
Wow.
Okay? And honestly, that right there is kind of why I like these problems so much. Okay? Because when something isn't there, it's not there. We don't have to find it. We don't have to calculate it. If it's not on the graph, we just put none. Okay? And it's a nice change of pace from having to solve for everything. It's just if it's not there, it's not there. So now, axis of symmetry. Does this graph get divided into 2 equal parts?
No, it doesn't.
No, because one side stops and one side goes forever. So axis of symmetry will be none. Now, where does it touch the x-axis at?
-2.
-2. How do I write a point? -2, comma, 0 with parentheses. Now, our y-intercept, where does it touch the y-axis at? So how do I write that point? All right, now, so when we look at if these are increasing or decreasing, we're just going to focus on going from left to right. We'll break it up as we need to go. So from left to right, what's happening? Increasing. The whole thing is going up. And so how would I write that interval? Okay, and we use parentheses there. Okay, does that graph ever decrease? So we just put none. Is that graph ever constant?
No.
So we just put
No.
none. Now we're going to look at the back. Okay, so we're going to do the same thing back here. We're going to start by just listing out what everything does and where we get it from. So our domain is our x values, okay, from left to right. Our range is our y values from bottom to top. Our min is just our y value, the greatest or the smallest. Our axis of symmetry, we just do what x equals there. Our intercepts, we're going to put a point, x and y. And then for increasing, decreasing, and constant, okay, you are going to use x values. Also from left to right. And you will always use parentheses, okay? If you want to put up here for domain and range, if you have a closed dot, you use a bracket. If you have an open dot or parenthesis or infinity, you will use parentheses, okay? Key information, okay? I'm just having us write this because the more we write it, the better it gets in our brain. The more we have it in our notes, because what can we do again? What did we do?
Use your notes on it?
Use your notes on the test, okay?
Wow.
So because of that, having that stuff here for you to refer to will be good for you, okay? Now, we're going to look at these graphs. So we're going to start with this one. For this one's domain, what is the leftmost x value? And it goes to parentheses or brackets? Brackets, because we have points. Okay, now, range. What's the lowest y value?
-2.
Okay, what's the biggest y value?
0.
0.
Oh, yeah.
And again, they both get brackets. Jairi, wake up. Okay, we're doing a lot of important stuff today, so you need to pay attention. Okay, now, what is our minimum y value?
-2.
What's our maximum y value?
0.
Is this graph, can it be divided into two equal parts?
Yes.
Yep. Where at? Where would half be? 0. So we're going to do x equals 0. Okay, now we're going to look at intercepts. How many times does it touch the x-axis? Twice. So we got to do 2 points. What's the first point?
Negative 2, 0.
What's the second point?
2, 0.
Now, how many times does it touch the y-axis?
1.
What's that point going to be?
Negative 0, 2, 0, negative 2.
All right. Now, if we look at this graph from left to right, we're going to see what's going on. So if we start on the left, what is happening?
Decreasing.
Decreasing. When does it stop? So this section of the graph is decreasing. So how would I write that section? Negative 2 to 0. Then it switches. What is it doing from there?
Increasing.
Increasing. Okay, so what is the interval that it's increasing?
0, negative 0, positive
0 to positive 2. And then is that graph ever constant?
2. No, it's not.
So what do we put?
No. None.
All right, now we are going to look at the next question, okay? So when I drew this, okay, I made it slightly misleading in that arrow right there, this side goes on forever, okay? Some people earlier were saying that the arrow made it look like it was a point that stopped. So I just want you to continue that line out like that so you can be very, very clear that it goes out, okay? So if you want to add that arrow so that it continues out, please do. Now, for our domain for this one, what is the leftmost point we have? 0. Now, is 0, is that an open dot or a closed dot?
It's open.
Open. Okay. Anytime you have an open dot, it will be very clearly an open dot. Do you see how obvious it is that that's an open dot? Okay. So that means we're going to have to use a parentheses there. Okay. If it does not have that open dot, assume it is a closed dot. Okay. Now, how far to the right does this graph go? Infinity. It keeps going forever. Okay. So our domain is from 0 to infinity. Now, our range. What's the lowest this graph goes?
Infinity.
But since it's going to the bottom.
Negative.
And what's the highest this graph goes to?
3.
But 3, will it get a parentheses or a bracket?
A bracket.
If it's not got a very, very obvious open dot, it means it's a closed dot. Okay, so that will be a bracket. Okay, we only use parentheses if it is infinity or an open circle. Okay, that is when we use our parentheses. Now, what is the minimum y value? Where is the lowest this graph goes again?
Negative 10.
So what would the min be?
None.
None. What's the biggest y value we get?
3.
So that's our min and our max. Does this graph get divided into two identical parts?
No, it doesn't.
No, it doesn't. So we were going to put.
No.
All right, now, how many times does the graph touch the x-axis? Twice. Okay, but one of them, does this one really touch it or is it not really there?
It's not really.
Yeah, can't equal it. So how many x-intercepts do we really have? 1. And what is that point? 2, comma?
0.
Then our y-intercept, again,
No.
that point's still not really there. So it needs to be?
No.
Now we're going to look at our increasing, decreasing, and constant intervals. So as this graph starts, what's happening?
It's increasing.
Increasing. So it is going up. How would I write that interval? 0 to 1. We only use x values for this. Okay, now, after it increases, what happens? decreases. So what is the interval where it decreases from?
1 to
Or okay, so it's talking about x values and it's on the right. So it would be
Negative infinity.
positive infinity.
One.
Okay, because it is on the positive x side.
Yeah, we use the X.
Okay, we have to use the x's. Now, does it ever constant? No. So we're going to say none. All right. Now we're going to look at this graph. Yes. Mhm. So this function right here is actually the graph of y is equal to the square root of x. That's what that graph looks like. And so what it's doing is it starts here, and then as it goes up super, super slowly, but it does go up, okay? That's because when you think about square roots, they kind of go up kind of slow. What's the square root of 1?
1.
What's the square root of 4?
2.
What's the square root of 9?
3.
So this is happening really gradually over time, right? It's barely going up, super slow. So now, when we look at this, what is our domain?
I don't even, it's like a curve.
What's the leftmost x value? 0 to infinity.
Oh,
And 0 is going to get a bracket.
because close.
Now, range. What's the bottommost y value?
0.
And then it goes up for?
Infinity.
Yep. And then again, 0 gets a bracket. So what's our least y value for our minimum?
0.
What's our greatest y value for our maximum?
None.
None, because it goes to infinity. Does this graph get cut in half?
No.
So axis of symmetry? None. Where does this graph touch the x-axis at?
0.
Where does it touch the y-axis at?
0.
Now, this graph, we start here. Does that graph ever, what is that graph doing?
Increasing.
So what would that interval be?
0 to 100. 0 to infinity.
And we use parentheses. And does it ever decrease?
No.
So we put,
None. Ms. Dawson?
Yes.
When Ethan comes back out to us,
yes. All right. Now, I want y'all to go ahead and do this one right here by yourself. It is very similar to the ones we've done so far, so I want you to go ahead and do that one. And I'll put this back up here if anyone still needs it. So go ahead and do that next question for me.
Ow.
I'm very, very glad. It will be nice to be done. And it'll be nice to get the pay bump. Because I have a bachelor's degree, I already have a Class B certificate, which gives you the base pay. Then, with a master's degree, you get a Class A certificate, which bumps you up. And I'm finishing my 5th year teaching this year, too. So that also will bump me up a little bit. So next year will be a nice little paycheck. About 14 grand? About 14 grand.
40 or 14?
14.
One.
That'd be nice.
You do like put those.
I would not be like Cody. Mega crashed out so much.
You know what I mean? Like you'd be a great history teacher.
You'd probably be.
All right.
I wouldn't be a jerk about stuff.
He would get in trouble for bullying students.
And letting them not follow the rules.
All right. So for this one here, what is our domain?
-2, 2.
Perfect. And they both get brackets. Our range is going to go from 0 to
Infinity.
2. Okay. This graph starts here, but it only goes up to there.
Oh, yeah, that's right.
So what's the minimum y value we got?
0.
What's the maximum y value?
2.
What does this graph get divided into 2 equal parts?
Yes, it does.
What?
At 0.
So we're going to do x equals 0. Now, how many times does it touch the x-axis?
Twice.
So we're going to put 2 points. What's the first point?
-2, 0.
Negative, comma, 0, negative 2, and then 0, comma.
and 2 comma 0. Where does it cross the y-axis?
0, 2. 0, 2.
So if you have noticed something about these, all of these have been examples of functions. And when we have a function, okay, it will only ever touch the y-axis one time. So that's kind of like why we can have multiple x-intercepts, but we really only will ever have one y. All right, now, so if I look at the first part of this graph, what is that doing?
Increasing.
Increasing. So what's that interval for increasing? -2 to 0. Then it switches to what? Decreasing. What's the interval for decreasing?
0 to negative, 0 to positive 2.
Is it ever constant?
No.
So we put,
No.
all right. Now we're gonna do the crazy looking graph right here all together. So for this graph, what is our leftmost x value?
It is 4.
What is our rightmost x value?
4.
Okay, and then both of those will get a.
Bracket.
What is the bottommost y value?
Negative 3.
What is the topmost y value?
3.
Now, what's our lowest y value?
30.
Mm,
Negative 3.
our highest.
Positive 3.
Okay, so finding that part, super straightforward, super easy. Everything else can sometimes get a little confusing. Does this graph get divided into 2 identical parts?
Yeah.
No.
Yes.
Okay, let's talk.
Oh, yeah.
So, that is where our axis of symmetry would be if we had one. Now, this graph is not mirror imaged. If you took this graph and folded it up, they would not match, which is what means the axis of symmetry means. It has to be the same on both sides. So this graph, if I was to take this part and slide it over, it would match the other half, right? So they are the same, but they're not symmetric. Symmetric means that both sides do the exact same thing. So it would have to look like that red part in order to actually be symmetric, okay? So symmetric means both sides need to be the exact same. They need to be mirror images of each other. They should look identical side by side. And because this one goes up, whereas this one goes down, it can't be symmetric, okay? So our axis of symmetry would be none. How many times does that touch the x-axis? 5. So we're going to put all 5. Okay, what's the first one?
Negative 4, 0.
What's the next one?
Negative 2, 0.
The next?
0, 0.
The next?
2, 0.
And the last one.
4, 0.
So all of those are x-intercepts. What's our y-intercept?
That's 0, 0.
0, 0. Now, this graph does a whole lot of increase, decrease, increase, decrease, increase, decrease, increase, decrease, right? So we're going to figure out how to write all of that. And the best way to do that when there's multiple increases and decreases is to just start at the left and go through the whole graph. So what is happening right here?
It's going increasing.
It's increasing, okay? So it means it's going up. What would that interval be?
Negative 4, negative 3.
Okay, then it switches. What does it switch to?
It switches to decreasing.
And what would the interval be for that decreasing?
Negative 2, negative 1.
Negative 3 to negative 1. Yep. Then what happens after that? It increases again. So to connect 2 intervals that are this like both increasing, you're going to put a U in between. And so where does that next interval need to start?
Negative 1, 0.
It's going to go from negative 1 all the way to where? Nope.
3.
X values.
Because,
1.
1 to 1.
Yep. Now, what happens after that? What does it do again?
Decreases, so you put U.
Yep, so we're going to have to use another U. And where will that section start?
1, 2, 3.
1 to 3. And then what happens in that last little tiny part?
Increases. It increases.
And so we need one more U,
3 to 4.
and it will be 3 to 4. Okay. Now, is there any place where it's constant? So we just put none. All right, now we're going to look at this last graph we have right here. Okay? And y'all, we are going to work pretty much till the bell. Today, we're gonna get through as much as we possibly can. So don't be immediately packing up. I'll give you time to pack up. Just wait on me to actually finish. Yes. Yeah, go ahead. All right. So for this one right here, okay, y'all don't need to leave today. Y'all really don't need to leave today. All right. So for this one, what is our domain?
-3 to 3.
What happens at both -3 and 3?
Open circle.
Open circle. So that means they need parentheses. Now our range, what's the lowest y value? What's the highest?
3.
Okay, so -2 for sure gets a bracket. Up here at 3, we have these points that are open, but next to them we have closed points. So is there a point that is closed at 3?
Yes.
So that means it also gets a bracket. The difference is because it's going up. There's multiple points at 3 up. But on the x-axis, there's only one point at both of those places. That's the difference. Now, what is our minimum y value? What's our maximum y value? Does this graph get cut into 2 equal halves?
Yes.
What? Where does that happen at? X equals 0. How many times does it touch the x-axis? Twice. Now, these are kind of weird points. Roughly, where do you think those are? And it's not 0.5. 0.75, yeah. So we're going to do -0.75, comma 0 and positive 0.75, comma 0. And then where would the y-intercept be? So how would I write that point? 0, comma -2. And then we're going to look at what's happening. So when we start right here, is that increasing, decreasing, or constant? Constant. How would I write that interval?
-3 to -2.
All right. Then it switches to what? Decreasing. Okay. So we have constant and then we have decreasing. When it's decreasing, what is that interval? And then after it decreases, it's going to switch to increasing, which it's going to switch to that what interval?
0 to 2.
And then what's the last interval going to be? 2 to 3, and it is constant. Okay. So what do I need to do before I can write that interval? And it'll be 2, 2, 3. All right. So from here, okay, we have our next section. Okay. I feel okay doing this in the last part for a very specific reason. Someone read this word to me.
Transformation.
How many times this year have we done transformations?
A lot.
So many. So many. Okay? So all we're going to do is we're just going to recap the rules that we've done 1,000 times today. Okay? So it is a translation. Okay? That slides or shifts the function. So if it moves left, right, or up and down, it's a translation. It is a dilation if it gets compressed or stretched. And what's it called if it flips the function? Reflection. Okay, so that's what we're just recapping those words. Okay, now we're going to go back through the rules that we've done 100 times. Okay, so if it is inside the function, it moves it left, right. So if it's positive inside the function, that's going to move it to the left. So it goes to the left, h units. Okay? If it's negative inside, what does it cause to happen?
Right.
It's going to go to the right, h. Okay? If it's outside, that's when it goes up or down. So if it's positive, it goes. And if it's negative, it's going to go.
Down.
Yep.
Miss Sullivan,
Yes, ma'am.
Emory Sales has a dismissal.
Yes, ma'am.
Thank you.
Now, if we have an A multiplied in the front, okay, it causes either a vertical stretch or a vertical compression. So if A is bigger than 1, so if A is like 2 or 3, what's going to happen to it? Yep, it will be a vertical stretch. Okay? And then if A is between 0 and 1, it's going to be a vertical compression. See you Monday. Okay, now, if it has that negative in front, it's going to do what? How is it going to reflect? Across what?
The x-axis.
So we're going to reflect across x-axis. All right? And we're going to go ahead and answer the questions on this page because it shouldn't take us very long. Okay? So we're going to describe the transformations. So for number 1, it is inside or outside?
Outside. Inside.
It's inside. And it's positive, so that means it goes to the
Left.
goes left 3. For number 2, is that inside or outside?
Outside.
So that means it's going to go,
Down. Downside.
all right? For number 3, is that inside or outside?
Inside. Or
Yep, and that's going to go to the,
right. 6.
for number 4, inside or outside?
Outside.
And that's going to go to the,
Down 3.
all right, now for number 5, it has 2 things happening. What does that negative cause to happen?
Compression.
The negative.
Oh, flip.
Yep, it's going to cause it to reflect or flip. Okay, then the half causes what, Caden?
Compression.
It is a vertical compression. Okay, number 6. Inside or outside? What does that plus 5 cause to happen?
Goes left.
Okay, number 7. What does the 4 in the very, very front cause to happen? And then what does the plus 3 cause to happen?
Left 3.
And then for number 8, what does that negative in front do?
Compression.
Reflect.
Oh, yes.
And then the plus 2 does? Left 2. Okay, so this is part of why I feel zero guilt about doing so much today. Because is this new? Is 90% of what we did today new? No. The only thing that's really new from today is the increasing and decreasing intervals. Okay, so tomorrow, let's recap. With the sub, you'll be allowed to finish your test from Wednesday. Okay, you will also have a Delta Math on what we did today. I will see you on Monday where we are going to finish the set of notes for Unit 10. Should you lose these? No. Why can you not lose these?
Use them on your test.
Is Miss Dalton going to print you a new copy because you were silly and lost them? No, she's not. All right, we are done today. And I will see y'all on Monday. Yes.
Ms. Dalton.